Yes, we are live and we started the recording.
Yes, sir. Thank you.
Shall I
Good
start? Shall I start or
Wait, sir. I
okay,
will
okay,
formally
okay.
introduce you first.
Oh yeah, yeah, okay.
Okay. Good afternoon to one and all. I, Mrs. Ashwini Patil, Assistant Professor, MES IMCC. Once again, welcome you all to this afternoon session of second day of online FTP on AI for Education, hosted by MES IMCC. First of all, I would like to tell about our institute, Institute of Management and Career Courses, IMCC, under the aegis of Maharashtra Education Society, is having 37 years of standing in the field of IT and management. It's affiliated to Savitribai Phule Pune University, recognized by AICTE New Delhi. We have MCA program, which is accredited by MBA, and we also have MBA program. In addition, we have recognized PhD Research Center under the Faculty of Commerce and Management, SPPU. Also, we have undergraduate courses, BBA, BBA IB, and BBA CA. The total student strength on campus is around 1,000. I would like to introduce today's speaker. It's indeed my great pleasure and privilege to introduce Dr. Rajendra Akerkar. He is professor of Big Data Technologies at Western Norway Research Institute. He also leads the Big Data Research Group. His primary domain of activities is Big Data and Semantic Technologies, with aim to combine strong theoretical results with high impact practical results. His research focuses on application of disruptive technologies to real-world challenges such as urban mobility, transport, and emergency management. His research and teaching experience includes over 29 years in the academia spanning different universities in Asia, Europe, and North America. He currently coordinates 5 major transactional research and innovation projects funded by the European Commission and the Research Council of Norway. He has authored 16 books, around 138 research papers, edited 2 ebooks, and 21 volumes of international conferences and workshops. I am happy to share that I was Akerkar sir's student when I was pursuing my MCA degree. With this brief introduction, I once again welcome you, sir, and I request you to start the session. Over to you, sir.
Okay, good afternoon, everybody, and thank you, Mrs. Ashwini Patil. And Outset, I would like to thank uh, Ravindra Vaidya for inviting me to this session. Uh, and It's actually my pleasure to be here and to give some my point of view, especially the European perspectives on evolving artificial intelligence and its landscape. Uh, so as I mentioned in my synopsis of this talk, what I'm going to do is I will present the AI's application across variety of sectors. Then I'll try to address some pertinent issues in its development and also suggest some recommendations and some ideas for getting the most out of AI while still protecting important human values. Yeah. So my talk is not about AI in education, though your seminar is on this topic, because from my background, you will see that I'm not working in the education field, no longer working in the education field, or not doing any AI in education. Uh, though I taught AI for 11 years uh, in India. So what I'm going to do is I will present a overview of current AI, uh, then what to do to ensure the positive use of AI. I will also present some interesting topics and areas, uh, mostly not just computer science, but also it's interdisciplinary fields. That will provide you some interesting ideas for research or research openings. Since you are teachers and researchers, knowing the latest development in the field and its constituents will help you to design your AI courses, then related projects or mini projects for students, and even interesting topics for your own research, and also to train your students in human-centered artificial intelligence in India. So it's a little bit about my background. Uh, as Mrs. Ashwini Patil said, I lead a big data research group in the Western Norway Research Institute. It's a small institute in the western part of Norway, but it's very, very active in big data and AI related research. We focus on the left-hand side, you will see a colorful figure. I think some of you have at least known what is this figure is about. This is the Sustainable Development Goals. So United Nations has uh, this collection of 17 interlinked goals designed to be kind of a blueprint to achieve a better and more sustainable future for all. These sustainable goals were set in 2015, I think, by United Nations General Assembly, and are intended to achieve by the year 2030. Uh, we are, especially my research group here, we are contributing to goal number 11 because we do research in the transport, mobility, then emergency management, that is disaster management, community resilience, energy utilities in these areas. So we apply big data technologies and artificial intelligence for this research. So this goal 11 is about making cities and human settlements inclusive, safe and resilient and sustainable. So we try to contribute to this particular goal. AI also promises to be a powerful tool in this pursuit of this UN Sustainable Development Goals. But for example, uh, it is counterproductive if the tools we use to achieve this sustainability goal create a spike in energy consumption at that same time. That is not a good thing. So for AI, there are some good advantages as well as some disadvantages. So my talk is about that. Uh, what we do. So my research group here is purely it's more international research group. We have people from different countries working on various different projects and initiatives, mostly funded by European Commission and Research Council of Norway. So our research focus is on identifying, also delve into different ways of representing and analyzing big data to make it amenable to value or to valuable to find valuable insights, discoveries. So these are some of the keywords which we are working on. So this is the just overview of different ongoing projects on transport, emergency management, energy utilities, and I will come to some of them as an example during my talk. We also have very solid transnational partnerships. with different countries. We have a partnership with universities in US, in Japan, Hong Kong, China, uh, and many countries in Europe. Uh, Currently, I think we have somewhat uh, the collaborations with different 80 organization in this on this globe. And recently, in one of our international research and education project, India is also mm, included, and IIT Indore is now a formal partner in one of our projects. These are some examples of our collaborations. We have some academic collaborations with different institutions and public-private sector yeah, and industry. The mostly industry and public-private sector is from Europe and UK and some other associated countries in Europe. And universities and our academic institutions are mostly the international from Europe as well as other non-European organizations. Okay, then now with this background, I begin with my talk. As all of you know, AI and machine learning are already changing the way we work, and the future will likely see some big changes. From smartphones to chatbot, artificial intelligence is already ubiquitous in our digital life. You just might not know, but the momentum behind the AI is building very fast, thanks in part to the massive amount of data that computers can gather about our likes, our purchases, our movements every day. So this AI technology is an interesting technical advance, and it will be used to do some very interesting things, but it does not represent an advance towards general AI. The human intelligence is much more than a pile of data and a big neural networks, for example. That way, AI still has a long way to go. And in order to reach the human intelligence, it needs still some more years of research. So John McCarthy defined AI as AI involves machines that can perform tasks that are characteristics of human intelligence. Indeed, one important reason to study AI is to help us better understand natural intelligence. AI represent concrete efforts, or tough efforts to understand the complexity of human experience in terms of information processing. It deals not only with how to represent and use complex and incomplete information logically, but also with questions of how to see, that is vision, how to move, that is robotics, how to communicate, the natural language speech, and learn, that is reasoning, classification, memory, etc. But not everyone is ready to welcome AI with open arms. Some prominent bigwigs warn about the looming dangers that artificial intelligence may pose to humanity. But why are these people so unnerved by this idea, the idea of AI. Let us see some examples. You must have noticed this. You must have read this in the some newspaper. This was first, I think, it was published in a Guardian, a newspaper from UK, that the Elon Musk thinks we should be very careful about artificial intelligence. He says that, or he said once that I'm increasingly inclined to think that there should be some regularity or oversight, maybe at the national, international level, just to make sure that we don't do something very foolish. Bill Gates also said somewhat similar. His point of view is the most scary application of artificial intelligence is for warfare. He says that AI has the potential to do a lot of good for humanity because it can sort vast quantity of data much more proficiently and efficiently than we humans do. Sometime around 2015, Professor Stephen Hawking said that efforts to create thinking machine pose a threat to our very existence. He stated that the development of full AI intelligence, a complete AI intelligence, could spell the end of the human race. Even very recently, one of the fathers of modern AI, a developer of deep learning, uh, Dr. Yoshua Bengio, thinks the same. Awareness and concerns are growing in general public also. Common man also thinks somewhat in this way. How will be this future of AI? Will it be like Terminator? I think you must have seen the film Terminator, that is evil, or like Star Trek, uh, like force of God. So what is it? So the question is, why is AI back in this news? As we know, mathematician Alan Turing and neurologist Gray Walter were two of the brightest minds who tackled the challenges of intelligent machine. The term artificial intelligence was coined for a summer conference at Dartmouth University, organized by young computer scientist John McCarthy. And very recently, even in 2014, 64 years after Turing published his idea of a Turing test that would prove machine intelligence, a chatbot, the chatbot is actually pretending to be Ukrainian 13-year-old boy, finally passed his test. But is the current fear about AI reasonable? What do you think? See some more examples here. What is this? Adimanav. It's a primitive person lit fires without knowing any of the thermodynamics, law of thermodynamics. What it says, that it's possible to invent something without understanding why it works. It is possible. It's possible to invest this without understanding the theory behind this. The same with the uh, flying machines. That is, this is our another example. The pioneers of flyers of aeroplane copied birds, but at that time they didn't start with theoretical thermodynamics. The thermodynamics came much after that. AI is similar, somewhat similar. We can build systems that display intelligence, but we are a long way from understanding what intelligence is. So this is the quest, what intelligence is. But why does it matter? It matters because AI is designed. It is a design. It is an artifact, a tool, because early iterations of inventions are often insufficient. It's the same as the lit fire or the first aeroplane flight. The first plane wings worked more by accident than by design. Now that we know why a wing works on a theoretical level, we can build much more efficient and effective ones. The same is perhaps true for AI. In order to understand the impact of AI on society and be able to assess how to design, deploy, and use AI in a responsible manner, it is important for us to know what AI is. That is what intelligence is. So earlier AI, now I tried to divide this AI into two. This slide is about AI 1.0, the earlier AI. Through the latter part of the 20th century, huge progress was made, mostly theoretically, or we can say at least theoretically, in improving our understanding of AI and how it could be used. So there is one figure from from one of my book. There are different constituents of artificial intelligence at that time. So since you are teaching AI or you have studied AI, you are familiar with these intelligence systems and traditional sources of knowledge, how it is encoded, how this knowledge is encoded in expert system, knowledge-based system, and different other decision support systems, rule-based systems, etc. So there are some major breakthroughs in 20th century. These breakthroughs are empowered by brute force measures, heuristics, then human coding of rules, rule-based systems, knowledge-based systems, and simple machine learning, that is pattern recognition. To put it very simple, machine learning is a way of achieving AI. And the field of study that gives computers the ability to learn without being explicitly programmed. So these are the breakthroughs and their developments in the AI 1.0. Now comes AI 2.0. Earlier AI can be called, as I said, AI 1.0, and now we are in this AI 2.0. It's a paradigm. It's a paradigm shift actually in science. I think some of you know that first three paradigm shifts, paradigms, initial three paradigms. The one is experimental, a theory, and simulation. These are due to Rutherford, Niels Bohr, and Oppenheimer. And now we have this as a fourth paradigm, which is known as data-driven science. So what has changed dramatically since those pioneering days is the rise of big data and of computing power, making it possible to analyze massive amount of data at scale. In a nutshell, extract and use knowledge from new data or new data-driven knowledge sources like social media, sensors, from traffic signals, from satellites, and also from the historical databases. So this is AI 2.0, that is data-driven. So in 21st century, AI, this new AI needs big data and machine learning to scale. Machine learning is a way of training an algorithm. This algorithm or training this algorithm so that it can learn. Huge amounts of data are used to train these algorithms. Real-time data is used to train these algorithms and allowing algorithms to learn and improve. Deep learning is a subset of machine learning, as some of you know, and was inspired by the structure and function of the brain. So in the 21st century, here are some good examples of AI empowered by big data and machine learning, deep learning. That's just examples of day-to-day life. We use Google Translate. There is also a DeepL translator. It's a very good languages. So translate from one language to another language. The speech-to-speech dialogues like Alexa, Siri, Cortana, etc. Autonomous vehicles are coming. There are already running some autonomous vehicles, autonomous trains in Europe and also in Japan. Then deep question answering systems like IBM's Watson. And of course, Robo Soccer. And there are some other. I haven't taken all this in this on this slide. But these are all different breakthroughs in 21st centuries. So constituents of this AI 2.0 are different or slightly different from the constituents of AI 1.0. Here constituent, the most important constituent is data. What we talk about when we talk about AI, we talk about ingredients in this new AI, such as data, algorithms, autonomy, learning, decision making, and robots, and so on. With AI, the very important question is how to avoid that it goes out of control, and how to understand how decisions are made and what are the consequences of consequences for a society at large. AI is becoming sophisticated tool in the hands of a variety of people, variety of stakeholders, including political leaders. Some AI applications may raise new governmental and institutional pertinent questions, such as ethical, social issues, legal issues. I will come to these points in the later half of my talk. And in general, have a significant impact on society for the good or for the bad or for both. So AI is not magic. As you all know, an algorithm is a kind of recipe. I think when you teach algorithm in your classes, or when you studied algorithm in your college or university, you must have, or you or your teachers must have given one example for our algorithm. That is, algorithm is a kind of recipe. When you make a biryani, you are also following an algorithm. That is a recipe. By itself, a recipe has never turned into a biryani. No, it's not possible. The end result of your biryani has more to do with your cooking skills and your choice of ingredients. The same applies to AI or AI algorithms. For a large part of results depends on the input data and the ability of those who trained it. So input data and the ability of people who trained it. So it is a human and machine collaboration. And in the same way, as we have a choice to use either vegetables in our biryani or chicken in our biryani to make our food, in AI, we also have the choice to use data that respects and ensures fairness, privacy, transparency, and other human values we hold very dear. This is what responsible AI is about. The decisions taken concerning the scope, the rules, the resources, as well as uh, other things that are used to develop, deploy, and use AI systems. Therefore, AI not just the algorithm, it is not just the data that it uses, but it is a complex combination of decisions, opportunities, and different resources. So it's not magic. So data, I said data, from data to intelligence, data to knowledge. So machine learning. On this slide, I try to give you a simple description. I think most of the speakers and on when they talk about data science or AI or machine learning or uh, any kind of augmented intelligence, they always compare this data science, machine learning, artificial intelligence. So that's why I also added this slide here. Uh, and machine learning is the key, you know this, to unlock big and large scale data. While it is true that big data and AI are very different operationally, even when they work well together, the key reason behind this partnership, is that AI needs tons of data to build its intelligence, and big data, the tons of data, that is big data, makes an enormous amount of data available that enables AI to become more powerful. So how to go from this data driven to AI driven? Moving from data driven to AI driven is the next phase of this evolution. From an industrial point of view, uh, AI means algorithm based and data driven computer system. And uh, I'm sorry. So it is AI is algorithm-based and data-driven computer system that enables machines and people with digital capabilities such as perception, reasoning, learning, and even autonomous decision making. AI is based on a portfolio of technologies, including algorithms for perception and interpretation of vast amount of information, that is data, and software that draws conclusions, learns, adapts, or adjusts parameters accordingly, and methods supporting human-based decision making or automated decisions. Nowadays, this AI is starting with data as a machine learning. This machine learning ramps up to its power curve. As AI evolves, it will have to cooperate with both algorithms and the processes. What I think is that this data-driven AI is working well today, but it will likely lead to, again, rule-based AI as the complexity and scope of problems expand. This is what I feel. Look at the sources of big data for AI 2.0. The big data is similar. It's similar to small data, but bigger. There is still no clear definition or single definition of big data. There are several definitions. But what I want to say is big data is somewhat similar to data, small data, but it is bigger. But at the same time, having bigger data requires different approaches, different techniques, different tools, different architectures, with an aim to solve these new problems, or real world problems, or old problems in a better ways. So there are also necessary conditions for collection use of big data. What are these necessary conditions? Infrastructure can be one. Instrument data sources like people, places, different things. Computing power is most essential. Processor, memory, bandwidth. So multi-farm cloud computing, kind of supercomputers for processing, then storage farms, millions and millions of gigabyte bandwidth, and of course, machine learning and analytics. So all these things are necessary. And the data is coming from various different sources, as I said, coming from different emergencies, from different national local data like mobility data, banking data, financial data, entertainment data, shopping data, and also the personal data. So we collect this. So this big data can be defined using different characteristics. So we use different V's to define this big data. So big data has volume. It has just big size and scale. So say, for example, up to some 50,000 sensors in the Airbus A380 or something, or some 8 terabyte data per day. Then big data has velocity. Another characteristic of big data is velocity, rate of data, streaming data, video streaming, etc. Sensor data, variety of data across different media data, sensors, images, videos, text data, relational business data. Then validity of this data. That means the trustworthiness, the reliability of data, the quality of data, whether data is a poor data or it's a good quality data. Missing data also. So all this is about the validity of data. Data collected does not suit targeted use cases. Then you need a different data. And then finally, value. It's the most important characteristic. What is this value? So value is usefulness and importance of this data. So data per se is not valuable. How to extract real value from this data is important. So use different data, big data techniques, data analytics, in order to extract the insights from this different or heterogeneous data. So the key to uncover this new information for better decisions is to find actionable data from this data. However, we have to always be aware of the negative impacts that could lead to poor decision making, like the usage of a fragment of this data. So avoid negative impacts, and if there are negative impacts, then use some techniques in order to diminish this negative impact and uh, explore the opportunities. I'll give you some examples here from some of my ongoing and past projects. They are from different domains, and you will see that this one is from one of our healthcare project that is about a system for healthcare developed in this region. We use relevant data sets. These data sets are captured in this health decision support system, linked data infrastructure. So we use semantic web technologies here. These linked data sets are used as a basis for the creation of a clinical decision support system, which can reason for individual patient data at critical time points in the care process, in their healthcare process. For example, when medical professionals or doctors are prescribed drugs, when they're prescribing drugs for the patient, this research and development is a combination of big data, artificial intelligence, and semantic web technologies. So in this healthcare industry, various sources of big data are included. That is hospital records, medical records of patients, results of medical examinations like X-ray, photos, etc., images, and other devices that are part of this Internet of Things. And then monitor life support parameters using improved smartphone or improvised smartphone. Then using low cost version of some kind of Apple Watch or Fitbit. Analyze this data for tell signals, notify and warn the users of impeding problems and all these things. So this was done in, and we have created a distributed knowledge base for in this project, and use that for some providing the help for clinical decision making. In one of our project, we developed for the transport, for the European transport. I'm the coordinator of that this major project, and this is one of the major Horizon 2020 projects coordinated by me. And in this project, we recently developed a roadmap for European transport and logistics, the future transport, the next generation transport, to enhance the economic sustainability as well as competitiveness of European transport sector. I hope you hear the voice.
Yes, sir. You are audible, sir.
Pardon?
You are audible, sir. Your voice
Okay,
is there.
okay. So the video is, can you hear the voice from the video?
No, voice from video is not audible.
It's not audible, yeah, okay.
So you
Okay,
need
then.
to, you
No,
need to, there is a one option while sharing the video that audio also to be played. If you take that option, then it will work.
okay. Anyway, I don't know how to find that option. Anyway, but just forget it. It's just music, so you can see. Just see the video. So this roadmap is actually emerged from seven different case studies we conducted in Europe on various different transport themes. Work with 14 different companies, from Deutsche Bahn to Siemens and some municipalities in Estonia to Amazon. So various different uh, cases about the transport and logistics are used in this. And here we generated and shared understanding of different big data landscape in transport and identified the complete holistic view on different opportunities, challenges, and limitations. And also the in-depth overview of this of relevant technologies for big data analytics and big data management was provided. We analyze data also in different domains, different sectors, different mode, and presented how application-specific benchmarking can be used in order to evaluate which big data technologies are most suitable for the domain, the transport domain. So you will surprised to see, this is one example of our issues which we identified or during this process. So these are just legal issues associated with big data. There are 13 different legal issues associated with big data. Sometimes we just ignore this, but these issues are very important. The privacy, data protection. So in Europe, we have this GDPR, the regulation for handling the private data, and how to flow a data, free flow data from one place to another, how to handle the intellectual property rights, etc., etc. These are the 13 different issues we identified, and then they provided how to tackle these issues in specific cases. Here are some other issues, basically the social and ethical issues. All these issues are not just for the big data, but also important for AI. Trust is very important for AI. And this is one reason that there is a fear in the minds of common man and as well as big wigs. The trust, surveillance. Many political leaders, they want to use this surveillance as a tool. So here comes a social and ethical issue. Then their privacy, data-driven social discrimination, etc., etc. There are also environmental aspects. There are also different environmental aspects we have to tackle. Different environmental aspects also when we use data and when we process data also. As well as there are some issues of transparency, taking consent, controlling, etc., etc. This is another example from the transport only. Like it's about researchers divided these road networks into super segments consisting of multiple adjacent segments of roads. It's like a graph that share significant traffic volume. Nowadays, the Google traffic prediction system consists of different components like a route analyzer that processes several terabytes of traffic information and constructs super segments, as well as a novel graph neural network model they construct, which is optimized with multiple objectives and predicts the travel time for each super segment. You can see it here. So this is novel machine learning architecture for traffic prediction. The biggest challenge to solve when creating a machine learning system to estimate travel time using super segments is the architectural one. How do we represent dynamically sized examples of connecting segments with arbitrary accuracy in such a way that a single model can achieve success? Model treats the local road networks as a graph. So here comes the graph theory again, the discrete mathematics, where each route segment corresponds to a node and edges exist between segments that are consecutive on the same road or connected through the intersection. In a graph neural network, a message passing algorithm is executed where the messages and their effects on edge and node states are learned by these neural networks. So from this point of view, super segments are roads subgraphs, which were sampled at random in proportion to traffic density. And a single model can therefore be trained using these sample subgraphs and can be deployed at scale. So this is one case. Basically, I have taken it from the Google Maps and the DeepMind collaboration. So this is one example of a transport data. Now you will see the different types of data and how this data is used to analyze and use it, the insights for the real world problem solving. Here is another case of big data from emergencies. Nowadays, there are so many emergencies like earthquakes, flooding, then the traffic jams, then congestion, traffic congestion, wildfires, so on, so many. What we need in these emergencies is providing the right information to the right people at the right time, and also in the right language. And not only that, but in the right medium. So we need to provide right information to right people at right time, in the right language, and in the right medium. This medium is either voice or video or text, along with the right level of details. See, there are so many right levels. The utility and potential of big data for emergency management or disaster management or crisis management is growing, but integration of big data into existing workflows and practice is far more seamless. See one example from one of my projects. So emergency services need to extract the important messages from the social media. So in this project, we try to develop a system which can be used by emergency service providers, that is the government authorities, as well as the common citizen. So both can interact with each other during emergencies. And emergency managers can use this social media data. They can analyze this data using our system and provide the some alerts and send some messages directly to the affected people. And we developed also guidelines for citizens as well as the emergency services in this project. In another project also we have currently we are working on this. It's a large scale project with 16 partners from I think 12 different countries. And in this project we are the goal of our project or this initiative, this is funded by European Commission again. It's about community resilience. It is to identify new strategies for improving on the processes of preparedness of local communities against any kind of emergencies, hazards, either planned hazards like a terrorist attack or unplanned, that is flooding or earthquake. So this particular project aims at bringing together the validity and experience of local communities. So we are working with different municipalities, different emergency services, different governments in different countries, mostly in Europe, and strategies and commitment of national and supranatural national actors to achieve this tangible impact on the way of resilience is understood and increased the resiliency in the local community. So our aim is at implementing the holistic framework of different studies. We are learning from different communities because different communities have different way of working, dealing with emergencies. Not all the things are useful for different emergency in different emergencies in different communities, but we can learn from each other. So we are collecting a huge inventory in developing a huge inventory that combines the different studies. Then we develop different methods. Using these methods and software instruments, we are going to develop from the next year the cloud platform, and that cloud platform combines the physical with the less tangible aspects associated with human behavior. So this research and development is a combination of big data technology, machine learning, social media analytics, and augmented intelligence. So this is very ambitious project, ongoing project. So you must have seen in this different examples, some examples from transport, mobility, then the emergency management and healthcare. I choose only 3 domains because we are working in these three areas, and these are some sample cases. So you must have seen there are different data, different kind of algorithm, different kind of methods we develop. So the thing is, there are now benefits and risks associated with this big data, associated with these intelligent algorithms. He who has a large amount of data can manipulate people in subtle way. But even the benevolent decision makers may do more wrong than right if they have a lot of access of a lot of data, big data. So how would behavioral or social control impact our day-to-day lives? So key question here is, can we explain decisions? What if the decisions made using AI-driven algorithms harm somebody? And how the decision was made, any decision was made. At present, we do not really understand how advanced AI techniques such as used in the deep learning or neural network really works. It can be extremely difficult to understand which features of the data the machine used and how they were weighted to contribute the outcomes. This is due to the technical complexity of such advanced neural networks, which need huge amount of data to learn properly. It is kind of a try and error. This poses ethical and societal problem. This example of a wrong decision is published in New York Times Magazine. Wrong decisions are critical in medical applications. AI system has been trained to predict which patients with pneumonia must be kept in intensive care. It predicted well, except in critical case, patient with asthma. The reason was training database did not contain the right data. Patients with asthma have been taken care well in other interventions, not recorded in training databases. Another example is facial recognition. Facial recognition is quite popular. It helps policing and law enforcement. So AI is biased in some cases here. This is a news published in, I think, in Atlantic and even in some other leading newspaper, international newspapers in 2016. So technically, this is a problem of bias. So technically, bias in machine learning is nothing but the errors in estimation or over understanding or under representing populations when sampling. Selection, sampling, reporting, bias. So suppose 2 people are tasked with developing a system to sort a basket of fruits. They have to determine which pieces are high quality and will be sold in the market, and which will instead be used in making the fruit jam. Both people are given exact same data, that is the fruit, and the same task. Given the same task and data, the 2 people are likely to have different results. This is possible. Perhaps one person believes in primary indicator of a fruit's quality is brightness of color. That person may sort fruit based on the how it is vibrant or how vibrant it is. Even though not all fruits are brightly colored, that person would send strawberries, for example, to the market and melons to the jam factory. Meanwhile, other person might believe that uh, unblemished fruit is the best quality. Even though fruits with protective rinds might look scoofy on the outside, ugly on the outside, but are perfectly fine on the inside. That person could send unripe strawberries to the market and ripe melons or bananas to the jam factory. Exactly same thing, logically and evenly when applied this criteria, we result into two different outcomes for the same basket of fruit. It's one thing to have an algorithm that marginalizes melons or unfairly salts bananas or cucumbers. But what happens when algorithm makes important decisions about humans? Then that's problem. So when algorithms are used, for example, to review loan application, if you are applying for loan, bank loan, that application is evaluated by AI system, or recruit new employees in the company, or in academic institution or universities, or assess potential customers. If the data are skewed in decisions recommended by such algorithms that may discriminatory against certain categories or groups that may be racial or gender, etc., etc. So this is problem. Another problem with machine learning or AI algorithms is causality. This is the limit of machine learning. So causality, in other words, grasping not just patterns in the data, but why something happens. Why is it is important? Why it is so hard? If you have good causal model of the real world you are dealing with, you can generalize even in unfamiliar situations. That is very crucial. We humans are able to project ourselves into situations that are very different from the day-to-day experience. Computer scientist whom I uh, 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 whose recent statement about AI I showed in the previous slide, that is scientist Benjio, says machines are not able to generalize unfamiliar situations because they don't have these causal models. Right now, we don't really have good algorithms for this. But I think if enough people work at it and consider it important, we will make advances. So this is one of very interesting research topic, causal reasoning. Another thing just is about the requirements of trustworthy. This is one example from the recent the European Commission's ethics guidelines. AI system designers and managers should use these guidelines to have ethical responsibilities, and other stakeholders like policymakers, politicians, public authorities, even academicians like you do have ethical responsibilities. And therefore, the emergence of AI ethics or responsible AI or the explanatory AI has come. This is as a major topic nowadays in European academia, industry, and also discussed in the government. Ethics. Okay. So responsible AI here, it is a danger is not, as I told you, taking over the world, but it is a danger of misuse and failures. Why? Because this is a famous statement of Norbert Wiener in, I think, in long ago. He made this statement, and you will see this in many books on AI. Uh, but what is this purpose? Purpose in the red color, and who are those addressed by the pronoun we? In my view, we refer to us all. We means us all: researchers, developers, manufacturers, providers, policymakers, etc., and all who directly or indirectly affected by AI systems. We all have different responsibilities, but we all have the right and the duty to be involved in this discussion of purpose we want AI technology to have in our lives, our society, or our planet, because AI and its impacts are too important to be left to the technocrats alone. So we need a responsible AI. This is again the slide from my previous some text taken from the previous slide. That in self-driving cars, who is responsible for accident by self-driving car? Can a car decide in face of a moral dilemma? So there are several questions, and we need to understand in way to contribute to human and environmental well-being, and that are aligned with our values, principles, and priorities. Uh, yeah, so the concept of agency is used by some researchers in AI. So this, let us see this AI from the perspective of the main characteristic of agency. Agency is nothing but capacity of individuals to act independently and to make their own choices. The concept of agency is also important or main or central to economics, in particular where it concerns the relationship between an agent and its principal. So there are several aspects of the three different aspects: autonomy, adaptability, and interactivity. So these are the three important things. Autonomy is perhaps the single most cited aspect of artificial intelligence. It is both seen as a synonym for intelligence as well as for the characteristics or characteristic of AI that people are most concerned about. So it refers the separation of concerns between the agent and its environment. Then comes the adaptability. At the heart of this concept of adaptability is the idea that systems can perceive their environment, that enables the system to take the most appropriate action or to use its perception to extrapolate possible future states. The main issue in adaptability is the capability to learn, which is a core of the machine learning. So responsible AI, we need this not just in design, but also by design and for designers. The responsible artificial intelligence is concerned with the fact that decisions and actions taken by intelligent autonomous systems, maybe autonomous vehicle or any other autonomous healthcare system or any transport system, have consequences that can be seen as being being of an ethical nature. So responsible AI provides a direction for action and can maybe best be seen as a code of behavior. It's a code of conduct. Then there are ethical behaviors also, ethical values. All of us know what are the ethics. The relation between AI and emotion raises many ethical concerns. Emotions are ultimately personal and private. Developing systems that are able to identify, display, or otherwise use emotions is seen by many as unethical. So this is also another interesting topic after responsible AI, ethical behavior, ethical reasoning. So ethical decision making. Famous example in decision making is trolley problem. You must have seen this somewhere. Given the increasing autonomy of the AI system and their deployment in the real world scenarios, as I explained in some of my cases, these systems will sooner or later encounter dilemmas that uh, demand some level of ethical reasoning. Much attention has been given to these ethical dilemmas self-driving cars that may face when deciding between the different actions, especially when harmful consequences for people. So this is exactly in this example of a trolley problem. So in trolley scenario is very hypothetical, but useful abstraction to consider how we want AI systems to behave in certain situations. So beyond autonomous vehicles, other types of AI system also need to comfort and resolve moral dilemmas. For example, an intelligent medical dispenser robo, so medical robo, may need to choose between two patients when it does not have enough medicines. A search and rescue robo during emergency may need to prioritize attention to some victims over others. Or in healthcare robo, uh, have to choose between user desires and optimal care. So these are very real world problems, very, very pertinent problems. And we still have no solutions to tackle this. So there are many issues of implementing the ethical reasoning. I will not go into details of this, but in order for an agent to apply the type of moral reasoning suggested by ethical theories, it first needs to be able to identify that it is in a situation that has an ethical dimension. And the most of these capabilities are currently out of reach of most of AI systems. And it's very dangerous. We need research, a lot of research in this. So we need a responsible AI. Using this in Europe, we use the responsible research and innovation cycle in every our project. And you will find material about this on internet. So I will not present this, but this is very important to realize that AI does not stand by itself, but must be understood as a part of socio-technical relation. It is not just technical, but it is a socio-technical. So some researchers have suggested this art principle. This art principle is the accountability, responsibility, and transparency principle based on the responsible research and innovation model, which I showed you on the earlier slide. And this also works with the design of values approach that provides guidelines to how AI applications should be designed, managed, and deployed so that values can be identified and incorporated explicitly into the design and implementation process. So this art principle are you will find this in some of the references which I have on the last slide. And then this is very interesting. Most of you are familiar with software engineering. You use software engineering design, software engineering approach. So this design connects the traditional software engineering concerns with the design for value approach. So far, we don't have this. So now we are coming up with this value approach to inform the decision of AI system. On the one hand, design of value, that is left-hand side, describes the links between values, norms, and systems functionalities. And on the other side, the domain requirements. Well, it's just like software engineering, a usual software engineering that shapes the design of software system in terms of functionality, non-functionality, and physical and operational demands of the domain, or in some sense we call it as user requirements. AI systems must obey both orientation, that is, it must meet domain demands and At the same time, ensure alignment with social and ethical principles. So this is a general life cycle for AI system, and the life cycle, the responsible development life cycle for AI system must ensure that the whole process is centered around evaluation and justification process. So every time you need evaluation and you need reasoning, justification for this. And we need machine learning is currently a core technology, and learning models are opaque, non-intuitive, and difficult for people to understand. So we need explainability. This is another research topic for AI, upcoming field of explainable AI. We need the explainability in AI, in so that is the ability to explain mechanically or automatically how the classifier made its decisions, how the network made its decisions, ability to explain how or why not AI systems work or make their decisions. So no AI without explanation. We need this explanation in AI so that every common person, user of AI, will understand. And the main idea is based on what features or factors or signal segments contribute most of the AI decision, reduce problem space. And that is to a manageable small problem. That is few key features and few key areas. And this apply a form of sensitivity analysis, some kind of trend of accuracy versus features used. So this AI explainability is not only a technical issue, it needs to be a user-centered, a human-centered. So what are the takeaways from my talk? I hope you have enjoyed at least some of the I enjoyed my presentation, and also here are some interesting takeaways from based on the previous presentation slides. The AI, like a fire or aeroplane, is here to stay. AI will not go. The question is no longer should we use it, but the question is how we should use it. So openness and explicitness are key. Optimal AI is explainable AI, and discovering what it means to be human. So we need human-centered AI. So let us work together on this human-centered AI. And I hope you will use some of the ideas presented in this talk for your future research. I suggested some interesting topics here. You will find some more information in these books. Here are some books are written by me or co-authored by me, and some books are also worth reading. A textbook and also books on latest books on responsible AI and explainable AI, etc. Thank you very much. If you have a question, you can ask.
Thank you, sir. Now we can take questions from audience if any.
I hope I haven't taken a long time.
No, sir, it is in time. No problem.
Okay.
Sir, Ghosh, sir, you can ask your question.
Hi, sir. Good afternoon.
Good afternoon.
My question is, in the GNN, that is graph neural network, how the traffic flow can be controlled while weightage is not given. And so we don't know the when what is the traffic congestion or density of the traffic, then how the system can be built?
Yeah, it's a good question. But I can send you some of the research material links which we are working on, or we did some research in this transport project, which will give you more information on that, because I'm not expert on all these deep learning things, so I can't give you the full description of what uh, uh, is done. We are a big team, and we work with different people, different organizations. So I can provide you some links. Maybe if you can share your email address, then you will get to know all the research related to this
I will
deep
mail you.
learning in our project. Pardon?
I will mail you in your mail ID.
Okay, yeah, sure, you
I
can
will
mail
mail
me. Yeah. Yes, yeah. This is very specific question, very technical question, and uh, um, but some of our cases, in one of our case study, we have tackled this issue while doing this Lemo project.
Yes.
Yeah, is there any other question?
Yes. If anyone has question, please raise your hand so that we can unmute you. So participants,
No.
do you have any questions? If no, then we can.
I think there are no questions. So
Yes. Yes. Okay. So now we are at the end of session. I would like to conclude this session. Uh, Thank you very much, sir, for this wonderful session. On behalf of IMCC and all participants, we sincerely thank you for accepting our invitation despite of your busy schedule and delivering the talk. We really appreciate and thank you for excellent coverage of the topics AI, big data, and also for demonstrating real world applications. Also for touching various current research areas in AI. And you have shared your ongoing projects also. So thank you for that. We look forward to connect with you again in our future college events. I also thank all participants for their patient listening and active participation. Now